switches.
Cool.
Hi, everyone. I'm Michael Lee, the founder of the Data Incubator. We do data science and AI training and placement. You'll probably know us best for our fellowship, which helps PhDs and master's students enter the industry as data scientists. The program is completely free for fellows to get in. And if you're interested, you can find out more at thedataincubator.com. We also offer a number of online courses for working professionals, or those who want to take their nights and weekends and use that to learn more about data science. And we also offer corporate training. And if you're interested in either of those, you can find out more at thedataincubator.com. So today, we're here to do another installment of our regular web series, Data Science in 30 Minutes. And it's a regular monthly series about data and its role in the world. Past speakers have included Kirk Bourne, Director of Data Science at Booz Allen Hamilton, Holden Corral, an engineering lead at IBM, and a core contributor to Apache Spark, Zubin Garamani, the chief scientist at Uber, Sam Swift, VP of Data Science at Betterment, who was also incidentally a former TDI fellow, and many, many more. And if you'd like to see some of these past episodes, you can do so at on our website. So before I introduce today's speaker, I want to remind everyone that you can pose questions in the YouTube chat area. We'll monitor those and we'll pose them to the speaker at the end of the talk. Now, you do need to be logged into your Google account to be able to pose those questions. So without further ado, I'd like to introduce today's speaker. Today, we're joined by my good friend, Field Cady. Field is the author of the Data Science Handbook, and he's a senior algorithm engineer at the machine learning startup Algorithmia. Previously, he worked at Google, the Allen Institute for Artificial Intelligence in Seattle, and several other big data startups. He holds a BS in physics from Stanford and did his graduate work in computer science at CMU. Field, do you want to take it from here?
Sure thing. Thanks so much for the introduction, Michael, and great to meet all of you. Let me just pull up my slides here and share. Okay, so the title of this talk is A Tale of Two Projects, Full-Time Consulting versus Data Science Consulting. A lot of people who work as data scientists have kind of a normal job, you might say, where they have one big employer and they work on sort of one project in support for the various analytics aspects of it. Other people are more consultants. Maybe they are really and truly consultants who work for a wide selection of clients, helping all of them with aspects of their analytics needs. Or perhaps they kind of function as in-house consultants. I know that a lot of very large companies like Microsoft will have data science teams who are not attached to any one project or branch of the company, but they move around between them. So from the perspective of the work itself, those people are in a lot of ways like true consultants. I personally have worked in both roles, and my goal in this talk is to help you understand what those two different work styles are like, which ones are maybe better suited to your interests, the stage in your career that you're at, and maybe you can kind of sense whether a role that you're in might be drifting one way or the other. So first, I'm going to give you a quick little slide on my own background so you can see where I'm coming from. I mentioned that I've worked in both of those roles, but obviously there's a lot out there that I've never touched. So you can make judgments about how applicable my advice is to what you're working on. Then I'll talk very briefly about the data science process, which I think most of us are familiar with, and then showcase how it played out in two projects that I have been on. One which was very much full-time, and the other of which was very much consulting. Then I'll highlight some of the differences between full-time and consulting data science as illustrated in those projects. And finally, review some of what I see as the pros and the cons of the two different work styles. And then we'll open it up for questions. So Michael already gave a pretty good introduction. My academic background is math and physics, and I really got started consulting. The bulk of my consulting time was at Think Big Analytics, which is it was a big data startup that was a purely consulting model. So I was working for clients in a very wide range of industries, ranging from tiny little startups up to these manufacturing behemoths, all of whom were trying to get into this big data thing, and I was helping them with the data science aspect of that. More recently, I have switched to full-time work. I was at a big data startup called Mana that was kind of a hybrid of full-time and consulting work because I did a lot of work with our clients. And then the Allen Institute was completely a full-time role, as is my current job at Algorithmia. And kind of bridging those two worlds chronologically is when I wrote the Data Science Handbook. So I think that most of the audience has done a fair amount of data science themselves, where you start with framing the problem and trying to turn a business problem into an analytics problem. Then comes the data, trying to understand which aspects of it are going to be relevant, extracting the most meaningful numerical features from the data, and then comes the modeling, and this is a very iterative process. Ultimately, your outputs tend to be either code that is running in production, maybe being the logic in some app, or maybe some kind of regularly generated report, or your output is human understandable presentations and graphics and things, trying to give insights. The two example projects that I want to talk about, the full-time one was the big thing that I did while I was at the Allen Institute. The Allen Institute has a search engine for scientific papers called Semantic Scholar. It's one of the big public-facing products that they have. And when I arrived, this website was running, but they didn't really have a good sense of what people were doing on it. They had Google Analytics, so they could see how much traffic is there, where are people landing, but they wanted to ask fine-grained questions that they just couldn't. So I was basically brought in to try and figure out what people were doing and set up the infrastructure to answer those questions. The consulting project, I was working for a client whose business model was basically to sell ad space on news articles, typically within a few hours after the news article was put up. And they wanted to charge people a fee for that ad space that was proportional to the amount of traffic that article was going to get in the next 30 days. The problem is they don't know how much traffic that's going to be, so I was trying to help with their pricing model. The full-time project at the Allen Institute with the search engine, again, when I arrived, it was just Google Analytics running. And they had been gathering a few months worth of clickstream data that was just stored in an S3 bucket. The first thing that I did was stand up a Postgres database and get all of that data loaded in, designing the tables, and use that to answer kind of the initial backlog of questions. And then as time went on, Postgres was replaced by Amazon Redshift, and rather than just these custom generated events, we ended up signing up with another company called Heap Analytics that does all of the clickstream tracking themselves, and they keep their tables synced up to Amazon Redshift. I created a Python library that people could use internally to access the data a little bit more easily than writing their own queries. And the final picture of everything looked kind of like this. There's a big Redshift database in the middle with two types of tables. There are tables of event data that's generated by this third-party vendor. And then there's tables of our own internal data, scientific papers, interesting facts about them, and that's generated as a batch process using PySpark. And then there's a lot of things that are pointing at this Redshift database. There's the Python library, there's dashboards, and I'm not actually sure what else people might have been pointing at it because the database was exposed to everyone. The consulting project, as I mentioned, we're trying to predict these page views. And the first question is, okay, well, what's with the data? And we ran into a lot of issues with the data that I will discuss in more detail, put together a very, very crude, simple model using a combination of Python and R. As the project progressed, we experimented with some more sophisticated models. And by the time the project was wrapping up, the issues we had found in the data, we more or less had to live with them and cross our fingers. And the fancier ARIMA models that we had used to model traffic ended up not performing as well as the original very simple model. So that was what we finally put into production. Now, I mentioned that we found some issues in the data. The first one was, well, how accurate is the data in terms of tracking what people are, how many people are seeing these news articles? We did that by comparing it against data that we got for a select number of the articles. And generally speaking, the data that we had for all the articles was in pretty good agreement with Google Analytics user counts. Not perfect, but good enough that we moved on. The other thing that was kind of an interesting discovery is the client figured that these ad spaces were always going to be sold within a few hours of the article going up, and that ended up not being the case. About half of the ad spaces they sold, the news article had only been up for a few hours. But the other half were for much more mature articles. The approach that we took for those sort of early posted articles was this is looking at the very simple, crude approach. Look at the first N hours and don't worry about which parts of those N hours were spiking, just how many people visited in the first N hours, call it 10 hours. And how does that relate to the traffic that came for the next 30 days? And I've got some scatter plots here that show traffic for the first 12, 2, or 24 hours versus traffic for the next month. And you can see that as the article starts to age, historical traffic becomes a better mirror of upcoming traffic. And the simple approach that we used was just to say, you know what, the traffic for the next, if you're trying to price this ad space 10 hours in, our estimate of the traffic for the next 30 days will be some coefficient times the traffic in the first 10 hours. And you'd have a different coefficient for 9 hours, 10 hours, and so on. And the fancier approach that ended up underperforming was to model the amount of traffic that's coming to the site using ARIMA, and there are a few different variants of that. Ultimately, none of them beat the simple approach. Those are the particular projects that I had in mind. Now let's back up and see what they illustrate. In the full-time project, yes, I certainly had to try and frame the problem, but once I understood what I was doing, the rest of it was kind of going through doing the work. There wasn't as much of a ramp-up time in trying to just find my feet. Similarly, understanding the data, once I figured out what the data was, I could just sort of carry on with the work. And most of my time was actually spent trying to come up with new ways to process that data, experimenting with different things, new ways to model it, and a lot of code that was running in production, systems that had to be live and performant. This is very heavy on software engineering. Obviously, I still had to do all stages of data science, but it was very focused towards some, not others. In consulting, typically every problem is completely new. For the work that I was doing, I'd never worked in that industry before. I'd never worked with that client before. I'd never worked with the data before. And so I had to, from a blank slate, figure out how their business problem could map onto an analytics problem that would actually address their needs. And this is, you're starting fresh with this process for every new project, every new client. Similarly, understanding the data. You've never seen this data before in pure consulting, and you have to really just very quickly figure out how to make heads or tails of it. And that ramp up takes a lot of time, in particular relative to maybe the length of a consulting contract. So there's less time to focus on extracting the best features. You worry about getting features that are good enough to move on to the next stage. Similarly, you don't get a lot of the opportunity to try and make a perfect model. You're trying to make a beeline for something that will work well enough. And certainly consultants often end up deploying code. I did in the example that I just gave. But many other projects that I've been on, it doesn't actually end up turning into live code. It's much more PowerPoints, maybe trying to sell the client on a follow-up engagement where code would be written. Consulting is just much more focused on presenting results to humans as opposed to outputting live software. So the first difference that I wanted to talk about in general between full-time and consulting work is technical depth. If you're working for a company full-time on one project, you get the chance to iterate and improve on models a lot. And you really can get to something that, okay, yeah, it took time and care, and you tried a lot of things that didn't work, but you got the fancy deep neural network to perform rather than fall on its face, or you got the nice Bayesian model to work, as opposed to consulting, which is like, okay, let's try and fit a line. Line doesn't work, let's try and fit a parabola. And basically, as soon as you find something that's good enough, you move on. In the full-time role, yes, you're trying to solve the problem at hand, but you're trying to do it in a way that simultaneously sets you up for solving future problems better. So looking at the work with databases that I was doing, a lot of the decisions that I made were motivated by, well, if I was doing this in Python, maybe I could get a result faster, but if I set up the correct database and make sure that I define good views on the tables and figure out how to use Redshift because I hadn't used it previously, and invest all of this extra time, that will pay dividends because it gets used not just for the project that you're on, but for multiple other projects that you're likely to tackle down the road. In consulting, in contrast, you are likely to be laser focused on precisely the project at hand, nothing beyond the scope of that, and how you can get most quickly to an acceptable deliverable. So that ends up being a lot of hacking in Python, or your language of choice. Python is mine, and you tend to use simpler tools that are more robust and don't require as much tweaking, and you get a very superficial knowledge of a lot of different technologies and approaches, but you don't really sink your teeth in as much, except maybe for your toolkit of your favorite things. The second big difference that I wanted to mention is the data. If you look at my full-time project, setting up the clickstream traffic for the site at the Allen Institute, the data that I came in using was this backlog of clickstream events that they'd been keeping track of. That's not the data that I ended up with, though. We went through several iterations of, okay, what should we gather? What are the problems with it? Can we go tweak the way that it's being gathered? And ultimately, let's outsource some of the data gathering to someone who does a really good job and documents it well. In consulting, my experience is the overwhelming majority of the time, the data that you see is what you get. You're not going to be able to request that they go back and gather in a different way. A lot of times clients don't actually even understand the data themselves. This is maybe data that's been hanging around for a while, or maybe the data came from another team that they maybe don't have the best communication with. I have very, very rarely in consulting projects been able to just get more data that is gathered in different ways. So typically in consulting, the approach that I always recommend is, of the data you are given, you try to zoom in on the subset of it that's relevant to the problem. You really try to just focus down on where you think the signal will be. And it can be a little bit exhilarating because you can get really cool results and insights really quickly. But it's also a little sad to maybe only ever touch 2 or 3 of dozens of columns in a table. And the final difference that I wanted to talk about is more of sort of the business side of these things. In full-time roles, often, not always, but a lot of times, people are very deep in the technical weeds, and they are less involved in sort of the big picture of how this analytics project applies to the company or trying to reframe it. Some full-time data scientists do more of that, but in my experience, overall, they do less than consultants. Consultants, in contrast, as I mentioned, every project is a new beast. It's likely in an industry that you've never had any exposure to, and you have to get sort of an idiot's guide understanding of whatever this line of business is, and quickly come up to speed on what their pain points are so that you can distill it all down into an analytics problem. There's often a lot more human interaction because it's a very conversation-based situation to try and understand their needs, and then also to explain what you've done. A lot of times clients maybe are not very experienced with data science. This might be the only data science project or problem that they have, and that's why they're hiring a consultant rather than just going to someone who they already have in-house. So when you're consulting, you should expect to spend a lot of time with high bandwidth communication to clients. And the final difference that I wanted to discuss is kind of the scope of your work. If you're a full-time employee, your project probably matters quite a bit, or at least people have good reason to believe that what you are working on is important. On the other hand, especially in smaller companies, the most important work to be done might not actually be data science. It's very common for the data scientist at a small to medium company to be put in a position where, sure, there's open data science questions that need to be answered, but they're not anywhere near as important as these dozen database queries that need to be written, or this software engineering work that needs to be done on the product. So full-time data scientists, especially at smaller or medium companies, are likely to kind of wear a lot of hats and spend portions of their time functioning not as maybe a senior data scientist, but a junior software engineer. In consulting, in contrast, you're pretty much always going to be doing data science or work that is directly in support of data science. So you're applying your trade the whole time. On the other hand, your project might not be as high impact or as important to the client. A lot of times clients, they're new to this data science thing. They're not sold on it. If they were really gung-ho, they would have hired a full-time employee. And they're trying to see whether it can give them value. And the project that they give you may or may not be something that they truly care about or are planning on acting on. You know, a lot of these PowerPoint slides just sit in a folder forever. And some of the worst aspects of consulting come in when there's politics. Sometimes a consultant is coming in to do a job that another group at the company can see as being, their purview. Or hiring a data science consultant can be a way for an executive to, claim that their branch of the company is ahead of the curve on data science. It kind of gives them some plausible deniability, but that's really what they're trying to get out of it, as opposed to truly using data science. Most projects, in my experience, aren't like that, but some of them have an aspect of it. So to summarize, I would say that the big pros of consulting are you see a lot of stuff. You see a lot of different industries. You see a lot of different tools. You get exposed to a lot of ideas and people. And you get very, very good at just ruthlessly cutting a problem down to something that can address the business need. So you can take very complicated problems, come up with a simple solution very, very quickly. On the other hand, there's a lot of overhead involved in consulting. It's not as exciting and interesting to just ramp up on the pathologies in every new data set. And a lot of times you don't get to go as deep into a problem as you might like. For full-time work, in my mind, the biggest advantage is that you get, and it's why I ended up switching toward full-time, is you get a deeper understanding of the problem you're working on, the problem space. You get to think very hard about what's the best way to solve this and model it, not what's something that gets it over the finish line. And depending on your temperament, doing work that doesn't fall under the umbrella of data science can be a lot of fun. I've really enjoyed like the software engineering work that I have done, even when I was officially there as a data scientist. The downside of being a full-time employee, maybe you don't like the non-data science work. That can be an issue. And the other one is sometimes people get bored. Once you have truly gotten to know an area and an industry well, you can sometimes feel like you want to move on to new, more interesting questions. So that was what I had. Thank you so much, and I'll open it up for questions.
Cool. Thank you so much, Field. So we have a number of questions from the audience. The first one is kind of geared towards someone who's just starting out their career, just graduated. How do I get my first job as a data scientist?
Oh boy. So that depends in part on what your degree is in. If you're most people who are trying to become data scientists are coming from a technical background. Computer science is very common, physics, math. And this is someone who just graduated, you said?
Yep.
Okay. if they were a year short of, if they were a year shy of graduation, I would have strongly encouraged an internship.
That sounds like a good idea.
Yeah. For someone who already has their degree in hand and is looking for a job, I mean, that depends. That if you can get kind of an internship or something similar, some kind of a foot in the door job, that's always a good way to go.
Yeah.
If your degree is in computer science specifically and you have strong coding skills, in my experience, are typically the limiting factor for a data scientist. If you have strong coding skills, you should probably be able to get a tech job, and most tech jobs, there would be a fair amount of room to transition toward analytics work. If you don't have strong coding skills and you're going into engineering or something like that, I would recommend get strong coding skills and try to focus on data-oriented aspects of whatever work you're on. The biggest problem that you will have in that case to get a data science job is in convincing people that you can do analytics work. So if you can get kind of a portfolio of modeling experience that you can talk about, that's what I would recommend.
So on that note, another questioner was asking, how can I make my GitHub look more appealing for a potential employer?
Oh boy, that's a good one. So good code quality is a huge thing. When I look at someone's GitHub, what I am most likely to do is at first just sort of navigate directly to some of the source files and see, does this look like it was put together by somebody who knows how to write code in a way that works in the real world. I have often said that I have never seen a data science project fail because someone wasn't good enough at math. I have seen many data science projects go down in flames because people couldn't keep track of their code. People didn't understand the basics of how to organize it, and that's typically the first thing that I try to look for.
So can you be more specific? What are some of the things you're looking for there?
If you have a kind of medium-sized project, call it 500 lines of code, ballpark-ish, give or take a few hundred, it should be pretty clear on a superficial perusal that there's a meaningful structure to the code. You know, it's reasonably modular, and when you start looking at the code itself, things are named in reasonable ways, and there's not a lot of distracting cruft.
Yeah, so not a lot of commented out code.
Correct. It should. Yeah, it shouldn't.
Conventions.
What was that?
Consistent naming conventions.
Yes. You should get the sense. Well, I should get the sense in looking at your code that, well, I obviously don't know all the details, but this looks like I should be able to figure it out. As opposed to, oh, Jesus, what was this person thinking?
Yeah. One thing I found that's been kind of helpful is to use a linting program. So PyLint, PEP8, JavaScript lint, JS lint, whatever you want. And you just sort of force yourself to accept the conventions of the people who wrote, whatever conventions are of the people who kind of made that linting service. And I think it's, you'll probably find it overly prescriptive, and perhaps so, but it'll probably get rid of a lot of bad habits that you have. If you find that your code, the code you write naturally does not conform to that to the standard of the linting service.
Yes, that's an excellent suggestion. Consistency in how you write your code is generally a lot more important than like making every decision correctly. Ultimately, most of these decisions about how you organize it are matters of taste, and a good employer won't really be judgmental about doing it one way or the other. But it is very important to have it be consistent, both to appeal to potential employers and just to keep things straight in your own head.
Yeah, nope, that's very true. So one question that I think your talk actually leads to is, it seems like consulting is a good starting point. It sort of forces you to focus on what is the point of all this analysis, and then ultimately maybe help, as you sort of go through and look at a lot of industries, it helps you kind of understand, oh, this is the industry I really want to focus on, or this is the problems, that domain or tool set that I really want to dive in on. Would you say that's the case?
I would definitely say that it is, with the caveat that you often don't get as in-depth an understanding of these industries as you might think. It's not like you can expect to get a good high-level understanding of every industry that you consult in. Typically, you are focused on carving out a problem that you can solve as quickly as possible. So you'll know a lot of details about the company you're working for and the project you're working on, but there can be huge, important parts of this industry that you don't know because they weren't relevant to that problem. So it's not like a crash course in the industry as much as you might think, but yes, you absolutely get a very broad exposure and get to see what you like.
Cool. And then the final question, are there differences in the work-life balance between full-time and consulting?
There are huge differences, and I actually put some of that content in my presentation at first, but then I took it out because most of them have to do with full-time versus consulting in general, not specific to data science. I will say being a full-time employee is fantastic in terms of benefits and stability. Consulting, in my mind, it's more dynamic and quick changing. I loved it when I was younger. Now that I'm a little bit older, I'm more of a full-time guy. You could put it that way.
Got it. And do you think that your younger self would not have appreciated some of the benefits that the full-time that you do now?
Yes, I definitely do. The stability of a full-time job and benefits and all that is just great. And the amount that you can kind of grow your experience and the list of really cool things you can talk about is pretty neat. On the other hand, consulting, again, it's exciting, and a very good thing in terms of work-life balance is you can kind of do as much or as little of it as you want. You can consult part-time very easily. Full-time-ish jobs are typically all or nothing. Very few people would hire you to do full-time work 20 hours a week or 10 hours a week. But consulting, you can ramp it up or down, at least if you're not employed by a consulting firm, as your life at the time requires.
Got it. So you were working at a consulting firm, right? At Think Big. How does that fit into this picture? Were you able to get some of the benefits, like, but literally benefits?
Yeah.
Healthcare, but still have some of the excitement?
Definitely. So I'll say, before joining Think Big, I was consulting just completely on my own. And then at Think Big, yes, I was a full-time employee of Think Big, but all of my work was for clients. Think Big gave benefits, which was fantastic. And there was very regular work. The hours were a little bit more set. I had the disadvantage of not being able to pick my clients. When I'm on my own, it's I can pick and choose what industries I want, and it's much easier to make calls about who isn't a good client to have. At Think Big, the majority of the time, I was given the project as opposed to deciding what projects we were going to work on.
Got it.
Yeah, so working for a consulting firm is kind of a hybrid between pure consulting and full-time.
Cool. All right, well, thank you so much for coming and speaking. I also want to thank the audience for joining us. I hope you really enjoyed this new installment of Data Science in 30 Minutes. And if you're interested in hearing more from Field, you can check out his book, The Data Science Handbook. And that's available on Amazon and wherever fine books are sold. If you're looking to learn a bit more about data science and maybe become a data scientist, you should check out our free data science fellowship for people with PhDs or master's degrees. And if you're sort of already a working professional or just have an undergraduate degree, we have online courses available for you, as well as corporate training options. You can learn more about our you can learn more at our website, thedataincubator.com. Thanks so much, Field.
Thanks, Michael. It's a lot of fun. Thanks, everybody.